So today I'm going to talk about what's next for CowSwap, which is a composable CoW, and I'm going to explain you why we're entering the era of composable CoW. And I'm Alex Viñas, the product marketing at CowSwap, and the talk is broken down into 3 topics: a brief history of how CowSwap came to be, what has the CoW journey looked like up to today, and then entering the era of composable CoW. But first, right, let's begin with a little bit of a brief history. So it all started with the famous formula, no? X times Y is equal K, that probably you all know, but you probably don't know that it was actually coined by an ex-Gnosis employee back in 2017 instead of by Uniswap. And the reason it was because Gnosis was developing the prediction market, and it needed a pricing mechanism to actually trade the outcomes of the prediction markets where market makers wouldn't provide liquidity, because if it's a big sport game or a big US election, then probably market makers are gonna have liquidity, but if it's just, is Alex gonna screw up his presentation, yes or no, then probably a market maker isn't gonna really provide liquidity. But when venturing into this price finding mechanism, into this formula, Gnosis foresaw that it already had a problem. And even after some discussions, even with Vitalik, they realized that the mechanism was actually flawed because it was vulnerable to front-running attacks. And this means that essentially the miners had the control of the trading outcomes, right? Because if the miners ultimately had the control of what bets set first and what bets settled second, then the market wouldn't be really fair. So back then, Gnosis took the hard decision to actually stay away from this mechanism and actually try to find a new one. And even though it kind of has taken a bit of a long time to play out for that decision, now we can at least confidently say it was the right call. And what was the price finding mechanism that Gnosis decided to venture in? And of course, it was auctions. And why did they decide to use auctions? Well, because auctions have several advantages compared to constant function market makers. The first one is that blockchains aren't continuous, so kind of using a continuous system for settling orders in an atomic system doesn't make sense. So in the case of first come first serve, these systems lead to what we have already been able to see, that it's just an arms race to screw retail, right? Only really advanced traders are the ones that are getting the fair price at the expense of retail getting the bad price. Then also, auctions are very good at dealing with multiple tokens, right? They can re-aggregate the liquidity fragmented that we have now. Even that we say we have, one stable coin, but if you think about it, there's literally 8 different stable coins. So if you treat them in isolation, you have a lot of liquidity fragmentation, but if you actually treat them on an auction, you can actually re-pool the liquidity together. And then lastly, because with auctions, you can add a lot of guarantees for the benefit of the trader. So instead of saying I'm selling this for $100, the trader can actually go and say, hey, I'm willing to sell this, what's the best price that anyone can offer. But most importantly, what we believe is that the ultimate guarantee that auctions can bring is the uniform clearing prices, right? The root cause of MEV is this price difference within the same block that is caused by the ordering of these trades in the AMMs. And if all these trades were to clear at the same clearing price, then there would be no actually a race to reorder these transactions. And throughout the year, throughout the time, Gnosis built different versions and of course learned different lessons. So the first one was in 2017, it was Dodge X. And this was because when Gnosis did the ICO, they used this Dodge auction system to actually allow their participants of the ICO to not get front run and to actually enter at the price that they were willing to enter with the typical Dodge auction decaying function. So then they thought, okay, well, if this has worked for us, we might as well just release this interface and mechanism so that other projects can use it. But back then, they already saw the problem that Dodge auctions are single order and they can't really re-aggregate liquidity, and they can optimize like other type of auctions will be able to do. But hey, 6 years later, still people think that Dodge auctions are innovative. Then in 2019, Gnosis worked on Diffusion, which was a zero-knowledge based exchange on auctions for Plasma, the friendly ghost, but the ghost kind of faded away really quickly. So this version never went into production. And then in the midst of DeFi Summer 2019-2020, Gnosis Protocol V1 was launched, and Gnosis Protocol V1 was the precursor of what we now know CowSwap, and it was this similar concept, batch auction mechanism, where the settling time was 5 minutes, but instead of tapping on-chain liquidity, it had its own liquidity pool. It also had solvers, and it even had concentrated liquidity. The only issue is that there wasn't an NFT or the bankless people shilling it, so not a lot of people knew about this. But the problem that this exchange had is that it was at the time that in DeFi Summer, the yield fight, the fight for the liquidity was very tough. So it actually took a lot of effort to bootstrap the exchange and to prove the network effects that batch auctions can bring. So it never really succeeded that much. And then 1 year later, in 2021, they launched a better version of DogeX, which is Gnosis Auction, which was for projects that wanted to do their IDO, which was initial decentralized offering, with clearing price based on the batch auction and also protection from MEV. And to end up in at the end of 2021 with what we know now as CoW Protocol or CowSwap, which is this batch auction settling mechanism that protects you from MEV, but instead of relying on its own liquidity pools, it's actually just a layer on top of all the AMMs. But what's cooler is that you are signing an intent to trade, and basically if within the same batch there is a counterparty that can offer the liquidity for your trade, then you guys are matched peer-to-peer, and there is no need to go to the AMM. And now let's explore a little bit the journey on how we got to where we are today. And CowSwap or CoW Protocol was always built for the 3 main users in DeFi. The first one, it was for retail, right? Because the whole idea was DeFi has gotten so complicated and so complex with the amount of trading venues, the amount of things that you need to take into consideration, like slippage, what are the right token pairs, the right AMMs to use for this type of tokens that I want to trade. So it's been extremely complex for people outside the space to actually trade at a good price. So the whole idea was hey, let's just abstract the retail from all these complexities and let the solvers, who are the people that execute the settlements on CowSwap, deal with all these on behalf of them. Then the second user was for multisigs, because the problem with multisigs was that basically all the AMMs or DEX aggregators, they force you to commit to a path, right? When you're trading on them, they actually tell you the path or the route that your trade is going to go with, and unless you sign with all the signers very quickly, your transaction is going to fail, because probably that path has become outdated by the time that you have actually gathered all the signatures. But then also, if you're a little bit fast, it still takes a little bit of time to gather those signatures. What will happen is that most likely by the time that the trade hits the chain, is no longer the ultimate path. So this is a problem, and this is why in CowSwap, if you're using a multi-sig, instead of actually having to commit to a path, you only specify what you want to sell, and the solvers will figure out. But most importantly is that the actual quote is created at the moment of execution and not at the moment of order creation. And then the last one for DAOs, because DAOs haven't had a really a trustless way to trade. And the problem that this has forced is that DAOs now have been sitting with a huge stack of cash in their treasuries, and they haven't been able to diversify properly. So it wasn't until we implemented ERC 1271, which is this version of smart orders, that DAOs haven't been able to actually break this barrier and achieve the powers that everyone in the space believes that DAOs can have. And now let's look at the model of the architecture. So first, CowSwap launched intents to trade as we know it, which is I guess the old meta transactions. But at the beginning, it was only for EOAs. And it was only for EOAs because EOAs have a private key. So they are the only ones that can actually create a message, a signed message saying, hey, I authorize someone else to do this trade on my behalf, as long as they fulfill the requirements that I write in this message. But if you are a smart contract, because you don't have a private key, you can't really sign a message. So this means that if you had to go to trade on chain, you had to use this method for the safe, which is pre-signed, and that's pretty annoying because it's worse UX. You actually had to pay, and in the end, the user had a worse experience. So it wasn't until the integration of ERC 1271 that this changed. And the cool thing about ERC 1271 is that instead of using an EOA, you can now actually create this signed message via smart contracts. And this is because instead of using the e-recover system that you're used for private keys, you use this interactive signature verification, which is called is-valid signature, that basically allows your smart contract to delegate the order placement for its behalf. And the cooler thing is that not only it allows you as a smart contract to trade via intent, but you can also trade trustlessly with on-chain guarantees, saying, hey, like, you know, I authorize this person to place the trade on my behalf as long as the conditions of price needs to be with this certain rate, or, you know, a slippage can be more than this, etc., are met. And then at the moment of order placement, your smart contract is the one that actually checks this, and if it's okay, then the order goes through, and if it's not okay, then the order is not placed on your behalf. And what were the first two implementations of smart orders? The first one was the CowSwap native e-flow, and it all started because a lot of people were complaining that when you went to trade on CowSwap, you were actually always forced, if you wanted to sell ETH, to wrap it into web. And this is because ETH is not an ERC20 token. So most of the people in general, even though they allow you, in reality is that in the backend they're abstracting you this wrapping process that the user doesn't see. But the problem is that you know, we needed a way for actually having this contract place the orders on behalf of someone. So basically, we developed this intermediate contract that what it does is just it receives the ETH on behalf of the owner, then wraps it and places the order on the off-chain order book from CoW protocol, so that then the solvers can pick it up, and once it's into the settlement, then it goes on chain and the user gets the token that they want. And then the second version was based on the CoW grants program with a collaboration with Yearn Finance, and it was this project called Milkman, which basically allowed DAOs to kind of still go through governance process for their swaps and not get wrecked. Because the problem until Milkman was that if a DAO wanted to trade, it needed to actually reveal a lot of information for their trade way too early in advance, which meant that by the time that the whole governance process was over, everyone knew all the details and everyone was ready to kind of like screw them over. So the cooler thing about Milkman is that basically it allows the DAO to just simply craft the order and sign it in a way that is, hey, I'm going to execute this sometime in the future in advance, and it will only be executable as long as these conditions are met. So in this case, you can use, for example, oracles or what we call price checkers, which can be like a Uniswap pool or whatever you want, to condition your slippage in that sense. So hey, whenever 7 days in advance this order becomes executable, it can only execute as long as it's within 0.5% range of whatever Chainlink Oracle says the price of ETH USD is. And then this Milkman is the one that actually places the order on the CoW protocol order book, and then it's relating to the solvers, and it's just like a normal order. But ERC 1271 have some drawbacks, and the main drawbacks are that they're quite gas heavy. You know, executing orders autonomously compute a lot of gas, which means that you need to be ready to pay a bunch of money for executing in this type of style. The second one is that they require trust. This intermediary contract actually needs to hold the funds for the moment that it's placing the order and until the order is fulfilled, which might not be a huge deal for a lot of people, but you know, when you're talking about a lot of money or when you're talking about DAOs, this can be a problem because you know it opens up a risk factor for attacking the DAOs. And most importantly is that overall, in general, especially, sorry, developers here, developers tend to be lazy, and single orders, you know, you have to sign each order each time, which means that reduces the use case a lot of the orders, because if you want to trade, I don't know, every month you have to create 12 orders and sign them 12 times, but each time that the order is placed, instead of just signing them all at once. So this is why, with the drawbacks of ERC 1271, we decided that, hey, we need to improve this, and it's time to create a framework around this, and this is why we created the composable CoW. And composable CoW is this conditional smart order framework that basically allows to turn your nosy safe or safe into an autonomous agent that is able to express its intent to trades. But most importantly is that, as I said, you can have on-chain guarantees that your intent to trade is going to be settled in the way that you have specified. Because within the composable CoW framework, you actually specify the order structure. And it all started because we had one contributor in the DAO that wanted to do TWAP orders. So he started looking at actually how to place conditional orders with ERC 1271. But again, the problem was like, I don't want to have to sign each time the order when it executes. I just want to create an order and then forget about it and know that it will actually execute. But what is the composable CoW architecture? Well, if we look at the current safe architecture, there are two ways of actually signing transactions. One is if you create the transaction right via proof hash, and the other one is if you do a threshold, which is gasless, which is what ERC 1271 actually does. But this is very limited. It compresses you in the amount of use case that you can do. But the developers at the safe, because they knew that they couldn't actually code all the scenarios that people wanted to do, they developed this thing called the fallback handler, which is this function that in the event that your safe doesn't know how to actually understand what they need to sign, they can delegate this call to another contract, which is called the fallback handler, that can actually do more complex stuff. So in this case, if we think about the fallback handler, it's just an additional contract nested to your safe that is able to understand more complex logic, and therefore you're able to do much more complex order type or signature. And in this case, we developed the custom fallback handler for composable CoW, which is based on iSafe signature verifier, which basically is just an ABI encoded function call to trigger a custom signer, which in the case of composable CoW is the actual contract of composable CoW. But what does composable CoW enable, right? The cool thing is that it allows you to execute unlimited orders in parallel, right? You don't have to worry about nonces anymore because each order is independent from them and they're created via a Merkle root, so there's no collusion within the orders. So you can actually deploy unlimited orders at the same time and not have to worry that they have to settle or trigger sequentially. And this is also cool because you achieve a lot of gas efficiency because all the orders are summarized in a Merkle root. And this becomes quite handy when you're a developer because you actually have a constant gas expenditure when it comes to creating, deleting, or replacing orders, because you just simply have to update the Merkle root and then all the structure is immediately updated. Then another cool thing is that it allows you to actually have the assets within your own safe. You don't need to delegate your assets when it comes to order placement, so you know that, hey, the funds are held in a secure way or in a contract that you actually trust. And then the composable CoW has 4 important parameters when it comes to the order. The first one is the handler, which is the contract that verifies the conditional order parameters. Then the second one is the sol. It's just basically a cryptographic way to kind of hide the order details so that no one can brute force the Merkle root and then try to front run the order that you've placed. Then the static data, which is the token you're selling, the one you're buying, slippage, and so on. And then you can have additional off-chain data embedded within your order. But now that we've seen the architecture, let's see what are the use cases of composable CoW. So for example, you can program automatic swaps to actually swap whenever you have defined a threshold balance to trigger. So for example, if you're a DAO that has to do a fee collection, you can say, hey, at the end of the month, actually every month, execute this type of swap and swap whatever the tokens I have into whatever the tokens I want. But most importantly, because if in the case, for example, of CoW protocol, we have a settlement contract that collects the fees of the users that they pay within the sell tokens, and sometimes the balances are quite high. So a way that we could cover our backs could be like, hey, the moment that the save that collects the fees is more than 5K, actually just trigger the swap and withdraw the swap output into another save that it's more controlled and it's not directly maybe like as attackable as this one. The second one is that it also allows you to do, for example, payroll, right? If you're a DAO and you have to pay salaries, you can automatically say, hey, I want to swap every month for these 10 contributors that I have. I'm selling my ETH into USDC, and you create all the orders at once. And say that some contributor in the third month leaves, and now you have 8. Well, instead of having to, replicate all the orders, you just simply have to update the Merkle root, and then all the old structure becomes invalid, and the new structure is already updated. It also allows you to create good after time orders, right? After this time, create this swap, which is actually like what we're using in the new version of TWAP that we're using on CowSwap. You just basically break the order into n parts that you have decided, and they become tradable based on the time limit that you have defined. It also allows you to create private conditional orders, for example, like stop loss. So this way it's also interesting because you can kind of hide the positions that you're taking in the market. Instead of making them public, you are completely private in the kind of strategy that you're following. It also allows you to create these orders that I guess are more specific for CowSwap. They're called wait for CoW. That basically the condition is don't trade this order unless I'm actually matched peer-to-peer against someone, and therefore I'm able to save the liquidity provider fees and also all the gas that I'm gonna spend for interacting with the AMM smart contracts. And what is even cooler is that it actually allows you to place all these orders in parallel and simultaneously at the same time. So really, like in composable cloud, there is no kind of restrictions. Whatever you can imagine to code is what you can actually place as a type of order. So yeah, now concluding, because I've been speaking for a long time. Composable CoW basically allows to turn your safe into your autonomous trading butler. Just think of like more or less like your Jarvis AI. And it allows you to place simultaneously conditional orders based on intent to trades, but the beautiful part is that you also have these on-chain guarantees that you define, so that in case that you might not trust kind of like the CowSwap system and give you whatever best price, or you might be not believing in CoW, you can actually code the guarantees that you feel comfortable with, and the order will execute based on those guarantees. So yeah, if you're interested in integrating composable CoW, please reach out, and if you have any ideas, please reach out also, because we have a lot of grants to give. And that's it. Anyone wants to ask?
So what I got briefly from the protocol, you are able to handle intent-based orders, intent-based transactions that you can bundle together to save gas, which goes into a smart contract that verifies validity of these intents, which then initiates the transactions inside my Gnosis safe to actually execute stuff on my assets, right? So that's account abstraction. You basically relabeled account abstraction for composable CoW. What happens when AA becomes standardized? What will be the game theoretic incentives for me to use composable CoWs instead of the already standardized ERC 4337?
It's a very long question. So, okay, you're right, there is account abstraction. But if you think we have been doing this sort of account abstraction
When it was not present, yes.
Yes, exactly. And now the thing is that basically you have this sort of account abstraction for safes that goes more beyond the fact of, because from my understanding, more or less, what account abstraction is focusing is more on kind of what CowSwap brings for EOAs, kind of like don't get any lead and so on. which we already do with the solvers, this just turns your safe into a more autonomous trading agent, which you can't really do with account abstraction because you're not using a special fallback handle. So basically, this is just a way to turn your safe into a, I don't know, a trading steroid trader, like, you know, TradFi kind of thing.
Okay.
That you can actually code. Like, for example, like if you have an Aussie safe, you can't really program very easily a stop loss, and which means that you always have to have your computer with you, because if the price tanks and you're in the beach, then you might get liquidated and so on. But with this, you can actually just program everything so that, hey, in the event that my collateral ratio, you know, just falls below this threshold, just actually create this smart order that I already have signed. It's just a matter of executing it, and then I'm safe. I get to be at the beach and don't have to worry about it.
Okay, thanks.
And is that done through safe modules or like safeguards, or do you guys write custom like safe modules, or what's the actual integration with safe?
Yeah, so it's the safe has these fallback handler contracts. So it's a custom signer for the safes. For example, if you want to use if you want to use TWAP today, you have to upgrade your safe because your safe doesn't know how to actually create these complex signatures. And then basically this module, that is the fallback handler, is the one that is responsible for doing now the signature, more complex. But yeah, similar to models.